So I'm basically running a bunch of concurrent sessions, some in the region of 30, 35 sessions. It's on a bunch of tables. There's, I think, about 20 odd tables, and then just numbered T. It's synthetic. They've got a bunch of columns. Data is synthetic. Just so you know, there's a mixture of nullable and not null columns, padded data, skew. So I've included skew, varied NDV, so it's quite a kind of mixed bag. And all of this was really designed, I kind of put this together, really just to get a feel for the effect of auto-indexing, okay? And then if we look at things like the total size, the database itself isn't enormous. It's a good solid size, 520 megabytes in terms of tables. It's only that big because I want the test to run in real time, because I want to show you the whole thing end to end. So that's the size of the tables. There's a whole mixture of different table sizes. And then we have things like the SQL statements look like this. They're a mixed bag. They have between clauses, in clauses. All of them pretty much are joined, so join up to 8 tables together. So it's a pretty solid kind of mixture of longer running. All the queries run fairly quickly, but it's a good mixture of taking the region of several seconds and in sub-millisecond. So it's a good mixture of different queries as well. So if you just take a look, you get to see sort of like the certain between clauses, just to give me the ability to have a reasonable number of rows on the input. We've got something like a whole bunch, like 1,600 different SQL statements. I think in the test you're about to see there's fewer than that to make the test run more quickly. And then there's also some updates as well. Okay. So I didn't stick with just read only. I want to give a mixture of read and read write. Okay, right. Let me check that's going. Okay, let me talk you through this. Test 1, that's my imaginative name for this. What test 1 does is it's initiating auto-indexing, the step, if you like. Normally this happens by itself, but in this case I'm initiating it for the sake of the test. So if you look at bottom left, this is the number of logical reads per business transaction. This is the thing we want to reduce. So in other words, for each business operation, we want to reduce the number of logical reads from the database. This is the system throughput. We're looking at about something like 1,000 business transactions a second, something like that. This is not a huge system. It's 4 core, basically a desktop PC pretty much. But it's pretty quick. I mean, the rate of a business transaction in this case is very short. It's essentially just a query. And as you can see, the queries are actually quite expensive. They're a bit on the bordering of what I would consider an OLTP performance, really. They're quite a lot of IOs per query. Okay, the other thing to notice here is the CPU is actually flatlining at 100%. It's right smack up to the top, which is, of course, somewhat artificial. The reason I'm doing this is because I want to, basically, the workload is pushing hard. It's pushing against the wall that is the database. So and for that reason, I want to demonstrate how the workload performance goes up when we get indexes. So in that sense, it's slightly artificial because pretty much, you know, I'm hitting 100% here. So it's a hard one for the system to deal with. What you're seeing here is the database has now seen some candidate indexes. It's created them invisible and unusable. And over here, some activity. What this means is we're actually test parsing SQL statements to see if they're going to use the indexes that we have available. So that's all it's doing at this point. In fact, so the scales do move a little here, but we've only got one statement at a time just being pushed through the system. Okay, so what we have now is, 38 indexes have been created. These are the candidates. They are invisible, unusable. Okay, so they're, of course, hidden from our workload. Our workload is continuing to progress happily. Now this is all happening, you know, at real time. I'm not kind of initiating this. So we are now creating these invisible and valid. So in fact, we looked at the candidate indexes and decided they're all going to be useful in this case. So we basically build them. Okay? So you just see a shift in scale actually, and then it'll sort itself out. But basically, this 38 indexes over here are going to be converted into invisible, valid indexes, 38 of them. Okay. So that little step finishes in a moment. Right, now the next thing we need to do is to see whether our workload benefits from this or not. Okay, we have the indexes. They are invisible, so our workload over here still does not see them. It's unaffected. Okay, this workload over here that's running has remained unchanged, and that's because we haven't made it visible yet. Okay, this is all going on offline, so to speak. What we see here now is this scale shooting up. What we're doing now is actually validating those SQL statements. We're figuring out whether the performance has improved or not. And in fact, that stage has been pretty fast and it's essentially just gone pop. Now what we have, all the indexes are now visible and valid. So now they are visible to the application. Okay? So what do we expect to happen at that point? Well, it'd be nice if the transaction rate goes up. That's the aim. It would be nice if the cost in terms of logical I/O of the transaction goes down. So you should see the effect both here and here. So we can see now it looks like we've got about 2,500 business transactions a second now. And we're down to, I think in the region, about 200 or 300 logical reads per business transaction. Okay. This is the ultimate aim, of course, of indexing. You know, one of the great benefits of it, of course, is we reduce the amount of I/O required per business transaction. In fact, in this case, I was quite lucky in that I got even a little dip in CPU, in fact. So it's kind of pushing hard against, presumably I'm now running out of disk or something. I've kind of pushed the workload further and further right up into the wall again. Okay, so that's the entire process. So it's 30 odd indexes, 500 megabyte database with a nice synthetic workload. If I add more queries, it takes longer because there are more queries to validate. So essentially this time period is defined by the number of queries I'm throwing at the system. And of course how busy it is as well. Obviously if you make a system this busy, it's going to slow down the process of index creation as well. But hopefully you can get some idea of how it progresses just by this demonstration. Okay? So what I'm going to do now is hand you back to Maria.